future semesters it will be required. Okay, that's what we are doing. It's a very important concept in circuit analysis. So this is how we found out R1, R2, R3 from RA, RB, RC. Now we have to do the opposite thing. That means we have to represent this RA, RB, and RC with respect to R1, R2, R3. Because today star will is given to us. That means R1 value is known, R2 value is known, R3 value is known. And from that we have to find out RA, RB, RC. That means we have to go in the opposite direction. Now for that, what we will do? Multiply. Let us say this is equation 1, this is equation 2, this is equation 3. Okay. First thing what we are doing, 1 multiplied by 3. So R1, sorry, R1 multiplied by 2, we will also do the 3. Okay. So R1, R2, if you multiply these two equations 1 and 2, that means left hand sides will be, left hand side of the equation will multiply, right hand side of the equation will multiply. So R1 in the left hand side, it will be R1 multiplied by R2, that should be equal to RA square, RB, RC in the numerator, and the denominator it will be RA plus RB plus RC whole square. Similarly, let us multiply equation 2 and equation 3. Okay, equation 2 and equation 3. So R2, R3. Left hand side multiplication R2, R3. On the right hand side, it will be RA, RB, RC whole square and RA plus RB plus RC whole square. Okay. Then multiplying equation 1 and 3. 1 and 3. So it will be on the left hand side, it will be R1, R3, and on the right hand side, it will be RA, RB whole square multiplied by RC, multiplying the numerators. Okay, the denominator, the same thing, RA plus RB plus RC whole square. Okay, now let us consider this as equation 4. Okay, equation 5, equation 6. Equation 6. Now adding equation 4 plus 5 plus equation 6. On the left hand side, it will be, you will get R1, R2 plus R2, R3 plus R1, R3. On the right hand side, it will be the denominator, in all the terms, the denominator is RA plus RB plus RC whole square. So the denominator, it will be RA plus RB plus RC whole square. Okay. In the numerator, you will get RA square RB RC plus RA RB square RC plus RA RB RC square. Okay. This is what we will get. Now, from the numerator, what you can do, you can take this RA RB RC common. Okay. Then if you take RA, RB, RC common from this term, if you take out RA, RB, RC from this term, then what will be left? One RA will be left because RA square was there. So RA will be left. In the second term, if you take out RA, RB, RC, what will be left? One RB will be left. Similarly, in the last term, one RC will be left. Okay. And in the denominator, it was already RA plus RB plus RC whole square. Now, in this you can cancel out, and it will be 1. Okay, so what you are getting RA, RB, RC divided by RA plus RB plus. Okay, so this is, let us say, equation 7. Now, using equation 7, you can find all the values of R1, R2, R3. Okay, sorry, you can find all the values of RA, RB, RC. Now here, see, if you compare equation 7 with, let us say, equation 4 or equation 1. Okay, comparing equation 7 with equation 1. In equation 1, what you can see, R1 is equal to RA multiplied by RB divided by RA, RB, RC. Okay, so if you see this term, this one, If you take this term, this is nothing but R1. If you see this here, R1 is equal to RA RB divided by RA plus RB plus RC. Okay. So if you take this, so you can write R1 plus, sorry, on the left hand side it will be same. That means this R1 R2 plus R2 R3 plus R1 R3. On the right hand side, if you consider this as R1, then it will be R1 multiplied by RC. So you can find RC to be R1 plus R1 R2 plus R2 R3 plus R1 R3 divided by R1. So RC you can find out like that. Similarly, so you have found out RC in terms of R1, R2, R3, some function. Okay. Now, if you see equation 2, in equation 2, it was RA RC divided by RA plus RB plus RC. Okay. So if you take this term common, this one, then what you will get? On the left hand side, you will get the same term, that is R1 multiplied by R2 plus R2 multiplied by R3 plus R1 multiplied by R3. That will be equal to, on the right hand side, it will be, this one is nothing but R2. R2 is RA multiplied by RC divided by RA plus RB plus RC. So this the highlighted region in black, that will be R2 multiplied by RB. So from this you can find out RB to be R2. Similarly, at the end, RA also you can find it. Using the equation 3, you can find out it is okay. In this way, you can, using this formula, you can move from uh, star configuration to delta configuration. Yesterday we did delta to star. Today, star to delta. Okay. With this in mind, we'll move to what was left yesterday, maximum power transfer theorem, and also using dependent source. So let us, so if you have any problem here, you already know this thing, I think star to delta, delta to star. Next, we'll move to dependent sources. Let us say the question is, a circuit is given to you. There is a 10 ampere current source. Okay. Then there is a 4 ohm resistance. Then there is a dependent source, diamond like sign, so dependent source. Inside plus minus is there, so it is a voltage dependent voltage source. And then on the top of it, it is written twice of Ix. Ix, some kind of a current. So it is a current controlled voltage source. Then the 6 ohm resistance is there. This RL value is not given to you. So you have to find out, find RL such that maximum power is delivered. Now we have already learned maximum power transfer theorem. That means you have to represent this circuit. The first step of maximum power transfer theorem, you have to represent the given circuit using either Thevenin's equivalent circuit or Norton's. Anything you can do. So let us do Thevenin's. That means so to find the value of VTH, you have to find the value of RTH, and you have to then reconnect the load. Now, in this circuit, if you use maximum power transfer theorem, then maximum power will be transferred when RL will become equal to RTH. Okay. So this thing we have done, Mr. Now, how to find the VTH and RTH for the given circuit? IX. Okay, yeah. IX is the current flowing through this. This is IX. The current flowing through this 6 ohm resistance. This is IX. Now, can you try this? I've already showed you an example about how to solve this Thevenin's or Norton's when there is a dependent source. What is the first step that you have to do? Let us find out. The first step that you have to take is remove RL. Step 1. You have to disconnect the RL. Step 2 is if you are trying to finding out VTH. If you are in the second step, if you are finding VTH, then you have to redraw the circuit. There is this. Okay. Then you have to find VTH. Which method you will use? There are many methods that you can use. I think one thing you can. What is 30 volt? VTH. Yes, VTH 30 volt. Then find out RTH. For others, there are many methods that you can use. One thing, just by seeing this part, you can see that you can use source transformation. That means there is a current source and in parallel there is a resistance. So you can convert it to a voltage source and the resistors in series. That you can do. Else, what you can do, you just seeing that there are two meshes. This is a closed, this is a open. This path is open, so this is not forming a loop. So what are the meshes? This is mesh one. This is mesh two. So if you use mesh analysis, then you can what you can do, you can consider the current I1 flowing through mesh one and current I2 flowing through mesh two. Okay, that you can do. Now, if you look at mesh 1, then there is nothing to do because 10 ampere source is already there. So I1 value is already given. So I1 will be equal to, and this I1 direction that you have assumed, that is same as the direction of the source. So I1 will be simply equal to 10 ampere. You have to do nothing in mesh 1 because we have already seen that in mesh analysis, whenever there is a current source in a particular loop, okay, then the current in that loop is the same value as the current source and same direction also. So I1 you have got. Then we don't know I2. So applying KVL, applying KVL in mesh 2. Okay, then if you consider I2, then I2 will be the largest. Okay, I2 will be the largest amount of current. So I2 will be flowing in this direction, clockwise direction. So for this 4 ohm resistance, you have to put the polarities plus minus because current is flowing from bottom to top and current flows from positive to negative part. So yeah, this is plus minus. The polarity of this dependent source is already given. And here also the I2 current flows through here. So it will be plus minus. Now applying KVL, if we start with this 4 ohm resistance, then it will be plus 4 multiplied by I2. Okay. Then in the next, if you move in clockwise direction, the next element you are facing is this dependent source. The dependent source value is minus of 2ix. And next, the next element that you are facing is this 6 ohm resistance. So it will be plus and plus sign you are facing first. So plus 6I2. That should be equal to 0. Now, one equation, two unknowns. I2 and Ix, both are unknown. Okay. So Ix, you can see Ix is in this direction. And you have considered I2 is also in the same direction. So this Ix will be nothing but equal to I2. Okay. This Ix will be nothing but equal to I2.
सर
हाँ
सर +4 I2 - I1 होगा ना?
कौन सा +4 I2
-I1
हाँ एकदम सही बोले हाँ एकदम सही बोले यहाँ पे क्या होगा यू आर मूविंग फ्रॉम +4 मल्टीप्लाइड बाई अब यहाँ पे दो करंट फ्लो हो रहा है फ्रॉम बॉटम टू टॉप देयर इज I2 and from top to bottom there is I1 and I1 you have already considered you have already found that it is 10. Okay, so I2 minus 10. Okay, because I1 is flowing from this direction and I1 you have found that it is of 10 ampere. So 10 ampere is flowing from top to bottom and from bottom to top it is I2. ठीक है? So 4 multiplied by I2 minus 10 minus 2Ix plus 6I2 and Ix is equal to your I2 because in this branch only I2 is flowing, no current is flowing through this path. So only I2 is flowing. So Ix will be equal to your I2 value. And in same direction also, I2 is flowing in this direction. Ix, the given direction is also in this. So Ix is equal to I2. So 4I2 minus 40 minus 2I2 plus 6I2 is equal to 0. So 8I2 equal to 40. So I2 will be equal to 5 ampere. Okay. If I2 is equal to 5 ampere, okay, if I2 is equal to 5 ampere, then what is the voltage drop across the 6 ohm resistance? Forget about Ix and everything for now. Okay, what will be the voltage drop? I2 is now 5 ampere. Okay, so 5 ampere current is flowing through this 6 ohm resistance. So what will be the voltage drop across this? 6 multiplied by 5. So the voltage drop across this will be 6 multiplied by 5, that is 30 volt. Okay, no current is flowing through this 3 ohm resistance, so no voltage drop will be there. The same 30 volt will be your VTH. So VTH will be equal to 30 volt. Okay, I think this is clear. Next, third step. In third step, finding out RTH. So the first step that you take in finding out RTH, you deactivate the sources. That means here you have to deactivate the current source. That means replace it with open circuit. Same circuit I am redrawing. That means you have to deactivate the current source. So that will be not be there. So the only thing left will be this 4 ohm resistance. this 4 ohm resistance is there, and then there is this dependent source, that means minus plus 2 ix, and then there is this 6 ohm resistance, ohm resistance. Now you have to find out the RTH if you look through these two open terminals. Now the problem here is there is a dependent source. The dependent source is dependent on some amount of current, but that current is not there because you have removed the current source or whatever source it is. If you have removed the active source or active element, that is whichever is supplying the power, then there will be no current that is flowing. So this dependent source will be of no use. You cannot find what will be the value of the dependent source. So that's why you cannot like in circuits where there are no dependent source, you cannot solve this circuit using that method. Because to identify how this dependent source behaves, you need to connect some kind of a source. Okay. Six ohm. I think 6 ohm is correct. Yes, 6 ohm. So you have to connect some kind of a source. So what we have told, there are other methods also. We will see the other methods of finding out this RTH when there are dependent sources. But the method we have already done, you have to connect a current source of value 1 ampere. If you do this, and then you find out what is the voltage across it, that is V. Okay, then if you find V, then RTH will be nothing but V divided by 1, that is V equal to IR, and the current you have put is 1 ampere. So that will be your RTH. Now, given this 1 ampere current source that you are externally connecting, now you have to find out what will be the value of this V. That means plus minus this V. Again, you can see there are two meshes. This is mesh 1, that is I1. This is mesh 1. You consider the current value I1. This is mesh 2. Consider current value I2. Considering mesh 1. So current direction is in this direction. So plus minus. Again, here current will flow like this. I2 will be opposing it, but we will consider I1 is the greatest. Okay, largest among all the other currents. So this will be plus, this will be minus. Now you have to start somewhere, starting with this 4 ohm resistance. Starting with this 4 ohm resistance, if you move in clockwise direction, then you will encounter plus sign first. So plus 4 I1. Then you encounter this dependent source, minus sign first. So minus 2 Ix. Again, in the next, moving in clockwise direction, you encounter this 6 ohm resistance, but you encounter the plus sign first. So plus 6 I1 minus of I2. That will be equal to 0. Okay. Now there are 3 unknowns, 1 equation. So you will need other equations also. That means let us first, now easy thing is, what is the value of I2? You have already connected a current source. So I have already told you that in mesh analysis, when there is a current source in one of the mesh, then definitely the current in that particular mesh will also be of the same direction and same value as the current source. Here I2 you have assumed to be in this direction. That means from top to bottom, this I2 is flowing in this direction. But the original current is in opposite direction. So I2 will be equal to the, since the direction we have assumed is in opposing with the current source. So minus sign will be there. So the magnitude will remain same, that is minus 1 ampere. This is the second equation. Third equation. What is the Ix? Ix is given like this. Ix is given like this. Now Ix will be, you have already assumed that current I1 is flowing in this direction, I2 will be flowing in the opposite direction. So it will be I1 minus of I2, and I2 you already found. So I1 plus 1 ampere. So this will be your Ix. Now putting these values here, 4 of I1 minus 2, Ix is minus 1. So this minus will get plus 6 I1 minus I2. Sorry, then Ix you have to put here. This is Ix. So minus 2 Ix. This Ix you have already found. That is I1 plus 1 plus 6 I1, and I2 you have found as minus 1. So this minus and this minus, you will get plus sign. It will be equal to 0. So 4I1 minus 2I1 plus 6I1, okay, minus 2, this minus 2 multiplied by 1. So minus 2, 6 multiplied by 1 plus 6 is equal to 0. So this is 8I1, 4. So I1 will be equal to half ampere. So I1 is half ampere. That means if you see this, forget about now I1 and I2. You have already found out what will be its value. So I1 is moving in this direction, and you have found out the value is half ampere. I2 is flowing in this opposite direction. Sorry, I2 is also flowing in the same direction. That means this direction. So
Sir,
I1 is
minus half है.
क्या minus half?
Sir, I1.
6 minus 2 minus half. Minus 4 minus half. So then I1, if it's minus sign, then it is in opposite direction, that is half. And the I2 is 1 ampere. It is flowing in this direction. So the net current will be 1 minus, so net current, that is Ix, or the current through this 6 ohm resistance. Current through this 6 ohm resistance. It will be 1 ampere minus of half ampere, that is half ampere. So this much amount of current, so net current will be flowing from top to bottom. Net current will be flowing from top to bottom, and it will be of half ampere. Okay. So what is the voltage drop? Voltage drop across this 6 ohm resistance. That is 6 resistance multiplied by the current half. That is 3 volt. Okay. The voltage drop across this 6 ohm resistance is 3 volt. That is plus minus. Here you are getting 3 volt. And there will be also a voltage drop across this 3 ohm resistance because current is flowing in this direction. Current of 1 ampere is flowing in this direction. So plus minus will be there, and 3 multiplied by 1. The resistance is 3, current is 1 ampere. So 3 volt will be the voltage drop. So this 3 voltage and this 3 volt will be added up to get the value of this volt. Okay. So here it will be 3 volt plus 3 volt is equal to 6 volt. Okay. So the voltage V, this voltage V, you are getting as 6 volt. So RTH will be equal to 6 divided by 1, that is 6 ohm. Okay. So VTH you have already found it to be 30 volt, and RTH you have found to be 6 ohm. So the equivalent, Thevenin's equivalent circuit will look like this, plus minus, it is 30 volt. The resistance is of value 6 ohm, and then you have to reconnect your load. The load value you don't know, but from maximum power transfer theorem, you know that when RL becomes equal to 6 ohm, then maximum power will be delivered, and the value of the maximum power, P max, will be V square by 4 RL. Okay, so V square is 30 square divided by 4 multiplied by RL is 6. So in this way, you can get the maximum power, and the unit will be what? So in this way, you can solve any circuit which have dependent source, and you have to apply Thevenin's there or Norton's there. Then you can use this method. Now you try one. Okay, if you have understood this, those who have not understood, please let me know in any of the steps. Those who have understood, please do the next one and tell me the answer again. Let us say plus minus a dependent voltage source, and beside it, it is written 2 of Vx. So Vx will be some kind of a voltage, so this will be voltage controlled voltage source. Then there will be 1 ohm resistance. Across 1 ohm, the Vx is given like this. Then there will be this resistance, 1 ampere, 2 volt, RL is there. Find value of RL such that maximum power is delivered. Find out. If you have understood this, then find this out.
Sir.
Huh.
Sir, can we use a 1 volt independent voltage source instead of using 1 ampere current source?
Then you have to find out the current, because okay, let me solve it in a different way, then your answer, your question will be solved. Okay, let us do that and see what happens.
सर यहाँ पे 4 कैसे आया 30 स्क्वायर अपॉन 4 इंटू 6 जो लिखे हैं.
हाँ, इसके लिए कल जो हमें वो शेयर किया था उसको देखना पड़ेगा एक बार. रुक जाओ, कल का अगर जो मटेरियल में शेयर किया था हैंड रिटन मटेरियल, उसको एक बार देखो. मैं ओपन करता हूँ, 1 मिनट. और yes, the voltage source, the other one who asks voltage, we will do that thing here. Okay, we'll solve in a different manner. But whatever is your idea, try to solve. At least find out VTH. RTH is a bit difficult. Okay, but at least find out VTH. And from where this 4 thing is coming, let us 1 minute. Give me a minute. Download it. Those who have understood, please try. Okay, yeah. So the 4th thing is coming like this. We have taken an example yesterday that the voltage source was there. Others, please, those who have no issue, then they can solve the problem. 6 ohm. Okay, this is the previous 3 ohm. Then what will be the find out VTH also? RTH will be 3 ohm, and find out VTH. for those who didn't attend yesterday's class, okay, what was the basic idea of maximum power transfer theorem? That means there is a voltage source, there is some internal resistance. Okay, why internal resistance? Voltage source, ideal voltage source, we have assumed that it has zero resistance. Ideal current source, it has infinite resistance, but in practical cases it is not the scenario. Okay, it has some resistance. Okay, so this is voltage V, and you have a load, you have a RL load. Now what maximum power transfer theorem tells that what will be the value of RL, what will be the value of RL such that maximum power will be delivered at this load RL. Okay, so to find out, we have to find out the power. Power is nothing but VI. Okay, yeah, VI and V. Okay, and I you can find out V divided by RS plus RL. Okay, V also you can write as I R. So it will be I square RL. Okay, put V by RS plus RL whole square multiplied by RL. This will be the power. Then what we did, we differentiated this power with respect to RL. Okay, and from that we have got and equated it to 0. That from that we have got RS is equal to RL. RL is equal to RS. Now this we put it here. P. V divided by RS also. RS is equal to RL. RL is there, so twice of RL whole square. V square is there and multiplied by RL. So V square divided by 4 RL. From there we have got it. Okay. Now let us get back to this problem. First find out VTH. The first thing you have to do is remove that means you are applying Thevenin's. That means this circuit you are trying to represent such that there is a single voltage source which is of value VTH, and there is a resistance which is of value RTH. Okay, and your RL will be there. Then you can if you can represent the circuit like this, then it is simple. Using maximum power transfer theorem, you can say that RL will be equal to RTH. But for that, you have to find out what is the value of RTH, what is the value of VTH. Then only you can find out. And then you can find that P max is equal to V square by twice of RTH or RL. Okay. V square, for finding V square, you have to find VTH. Middle resistor is not given. Okay, this is 1 ohm. This is 1 ohm. So the first thing you have to do is remove the RL. The first thing you have to do is remove the RL. So your circuit will look like this. Your circuit will look like this. And try to find out what will be the value of VTH. Try to find out what will be the value of VTH. There is a single mesh is there. This current source value is 1 ampere. This is open, so no current will be flowing. Only current will be flowing through this mesh or loop. Okay, so this is mesh 1. So what current will be flowing through it? There is already a current source. So the current that will be flowing, that will be of 1 ampere. You don't have to use consider some variable and anything. The current value RTH is 5 volt. RTH is 5 volt. See. So you already know what is the current value, because this current source is there. So definitely this 1 ampere current will be flowing through this 1 ohm resistance, because ideal current source, it always tries to maintain a same value of current through whichever terminals it is connected to. Okay. So it will try to that much amount of current, 1 ampere current will be flowing. That 1 ampere current will be flowing through this 1 ohm resistance. Current cannot flow through this path because there is open circuit. That same amount of current will be flowing through this path. Okay. So if the current flows through this 1 ohm resistance, that means this will be plus, this will be minus 1 multiplied by 1, that is 1 volt. 1 ampere current flowing through 1 ohm resistance, that is 1 volt. Same amount of current is flowing through here. Again, this is 1 ohm and this is, and 1 ampere current is flowing through this. So 1 multiplied by 1, this will be your 1 volt. And this Vx, you can also see it is equal to 1 volt, because Vx is in same direction as the direction that you are getting. And the magnitude will be then same. Vx is equal to 1 volt. Direction is same. Magnitude is same. And if Vx is 1 volt, then this will be 2 multiplied by 1, that is of 2 volt. Okay. Now, what you have to do? Let us consider this as a voltage source. Okay, this is plus VTH. Now, if you apply, if you forget about this loop, okay, this one. If you apply KVL in the outer loop, if you apply KVL in the outer loop, then what will happen? If you apply KVL here, again, minus, again, moving in clockwise direction, let us say, moving in clockwise direction, you are applying KVL. So you have to move in clockwise direction. You are facing the minus sign first. So minus 2. Then facing the minus sign first. So minus 1 volt. This is minus 1 volt. Again, this we are getting because 1 ampere current is flowing and everything is happening through this 1 ohm. That's why 1 volt, but minus is there. So minus 1 volt. Again, minus 2 volt and plus sign first. So plus VTH, that will be equal to 0. So VTH, forget about this volt sign here. So VTH will be equal to, minus sign is there, you take on the other side. So it will be 5 volt. The problem is why you will get a wrong answer here. Because if you consider this part, that is, this 1 ohm resistance is there, and across this 1 ohm resistance, like 1 volt was there. Okay. And then current source was there of 1 ampere. Then if you consider, okay, this path, I will consider this path, it will be incorrect thing, because now you are seeing the voltages. VTH will be whatever the voltage at this point plus 2 volt. Okay. What will be the voltage at this node plus 2 volt, that will be your VTH. But which voltage you will take? The voltage across this branch or this branch? That you have to consider. Again, you know that parallel connection of voltage sources are not possible. Okay. So that's why you have to consider the outer loop. Okay, if you apply KVL in the outer loop, then you will get this correct answer. Otherwise, if you take only one loop, let us say if you are considering only one loop, then it will be incorrect. Then it will be incorrect. So your VTH will be of 5 volt. Please let me know if you have any doubts. When you are applying KVL, that means you are considering the voltage sources. Means again 6 volt, then V equal to IR. So you are all considering the voltage source, and voltage source cannot be connected in parallel. That you have to see. Okay. Then it is RTH. How to find RTH? In the previous method, what we have done, what was the problem in finding out RTH when there is a dependent source? That when you are removing any sources, RTH, the first thing we have understood till now, the first thing you have to do, you have to deactivate the any kind of source. If it is a voltage source, you have to replace that with short circuit. If it is a current source, you have to replace that with open circuit. Yeah, it's okay. But when there is dependent source, and if you are removing the sources, then the finding out what is the value, actual value of dependent source, how it is behaving in the circuit, that becomes very difficult. Because you have removed all the sources, and dependent source always depends on some kind of other voltages or other current. You have removed the sources, so no voltage, no current will be flowing through the circuit. So how will you see that means how this the dependent source will behave in the actual circuit? That thing you are not considering when you are deactivating the sources. That's why one of the method is just okay, deactivate the available sources and you apply a external source there, like 1 ohm, 1 ampere current source you are applying. What other things you can do? This was the circuit, let us say. That means there is this voltage source plus minus 2Vx. Then there is this current source as a resistance, and then there is this resistance and this current source. This is a value 1 ohm. So value 1 ohm. This is 1 ampere. There is a 2-volt battery, and this is plus minus VTH. Oh, sorry, VTH I have already found. RTH. Now earlier what we did, I am giving you another method. Okay, so that things becomes clearer, more clear. Now what earlier means in the previous case we have done, we have connected a current source here, 1 ampere. Because what is the reason? Applying the 1 ampere 1 ampere current source, we are trying to find out this voltage V, and then what we are trying to, then we are finding out RTH by V divided by 1 ampere. What other things you can do? Like someone is telling a voltage source. Why not? Let me just sort these two terminals. And let me find out what is the current flowing through this I. What is the voltage across this? Then you don't have to find, because the voltage across these two terminals that you've already found, that is VTH. That is VTH. The voltage across these two terminals is already VTH. If you find out what is the current flowing, then RTH, you can find out VTH divided by I. This is another way. If you are not connecting external source, then you do, then the other thing, you don't deactivate the original source also. The original source was okay, original source is already there, no issue. The original source is this 1 ampere current source that you have not deactivated. The source is already there. Now what you are finding out this current I, that is flowing through the short circuit. VTH, the voltage across these two terminals that you have already found out. So RTH will be VTH divided by I. Okay. If this is the case, then what you can do, you can consider two mesh 1, mesh 2. Consider current I1 flowing through mesh 1 and consider current I2 flowing through mesh 2. There is a current source that is common to both mesh 1 and mesh 2. Why I am taking this path? Because I want to also let you practice super mesh. Because there is a current source now that is common to both the path, both the mesh. So you have to consider the concept of super mesh. Super mesh, that means now if you apply super mesh, if you consider the super mesh, that means you don't consider this branch. You write the equation of the super mesh. That means again minus of 2Vx current flowing in this direction. So it will be plus 1 multiplied by I1, then this 2 volt, and you are facing the minus side first, so minus 2. Okay, and current is flowing through here, so that will be equal to 0. Again, this is plus, sorry, okay, plus minus is Vx.